Hi, my name is Mary Watucky, and this YouTube lecture is on respiration, specifically external respiration. Respiration is the process of inspiration and expiration. Inspiration is described as breathing air into the lungs, and expiration is described as pushing air out of the lungs. External respiration occurs in the lungs and is defined as the exchange of oxygen and carbon dioxide, specifically with the blood. So the air is going to oxygenate the blood, and the blood is able to then get rid of the carbon dioxide, and that's what you breathe out as carbon dioxide. There are three types of respiratory volumes that can be measured. One of the respiratory volumes is called tidal volume, and it is the total amount of air that is inhaled and exhaled in one breath. The next respiratory volume is minute volume, and it is the total amount of air that is inhaled and exhaled in 1 minute. And residual volume is the amount of air that is left over in the lungs after a complete tidal volume or a complete expiration. So if you, the maximum amount that you can breathe out like that, whatever the air that is left in the lungs is going to be the residual volume. So there's a tidal volume. I made a little paper. So if you have 500 milliliters of tidal volume and you breathe 10 breaths per minute, you multiply the 500 milliliters by 10 breaths per minute, and that will give you 5,000 milliliters of air per minute. So that's how you can find out how much air or how much volume of air you're breathing in and out in 1 minute. Let's see. Okay, so when atmospheric air is inhaled into the lungs, that air is going to be have very high levels of oxygen and very low levels of carbon dioxide. And in the blood, in the pulmonary capillaries, the pulmonary capillaries are going to have very low level of oxygen and a very high level of carbon dioxide. So when you breathe in air, the atmospheric air will go down into your lungs, and they will go to structures called alveoli, and they look a bit like this. And then the pulmonary capillaries look a bit like this structure. And that's going to flow the blood through them in order for the blood to get oxygenated. So the blood is going to go in this direction towards the heart. So the alveoli are going to have high levels of oxygen and low levels of carbon dioxide. So in order for the blood to receive oxygen, it must diffuse from the alveoli to the pulmonary capillaries and vice versa for carbon dioxide. So right here, I just have an alveoli, and then I labeled with high levels of carbon dioxide for the pulmonary capillary, low level of oxygen for the pulmonary capillary. I did the same with the alveoli. So, like I said, the carbon dioxide and oxygen is going to diffuse from high concentrations to low concentrations. So the carbon dioxide is going to go from the pulmonary capillaries to the alveoli, and the oxygen is going to go from the alveoli to the pulmonary capillaries in order for the blood to receive oxygen. So it's going to look a little bit like this. So then your end product is going to just be the blood. It's going to now have high levels of oxygen and low levels of carbon dioxide. And that's going to happen, that process is going to happen every single time you breathe in and out. So it's happening continuously every single day as you're breathing. I will talk a little bit about internal respiration, just to get a little bit into it. I'm not going to go too much into it. Internal respiration occurs throughout the body. It's going to be not just from your lungs to your blood, but it's going to be from your cells to the tissues and everything inside your body. You still will get that air from the outside, and you still need to inhale and exhale for this process to happen, for internal respiration to happen, but it's just going to be through cells of carbon dioxide, and oxygen is going to be exchanged, and through just your circulation. So that's all I have for today. That is respiration, external and a little bit of internal. Thank you.